This video will show how IgentForm can create an advanced shape structure. We will start with a grid definition to make it easier to introduce the solid contour. The program can define any set of rectangular or radial grids. We select a rectangular grid and position it appropriately in the coordinate system. In IgentForm, in the solid construction mode, the model is created from solids, where each solid can be independently parameterized. So we move on to the definition of the contour of a solid. We use a previously defined grid. The program will automatically snap the entered points to the grid nodes. When defining a contour, we can always return to the previous point using the undo option, as well as use different modes of snapping. In this case, the option of snapping to a point with any shift was shown. We can also use a DXF file as a background. The program will snap the entered points to the ends of the lines. After closing the contour and specifying the thickness of the upper slab, a new solid was automatically created. For better orientation in the project, we can display the outline of a solid at any time. The next step is to define the height of the solid and the number of stories. These parameters can be freely changed later, and the elements defined so far will automatically adapt to the new geometry. We will now define the columns. First, we can change the default cross-section and introduce further elements in the desired places. After defining each element, it is possible to display a dialog for validation and possible modification of the entered data, for example, cross-section, material or offset. In this example, the default settings are accepted. Beams can be defined in a similar way. A simpler way will be shown here. If beams are on the contour of a solid, it is enough to select the appropriate lines, turn on the beams, and set the section. The next step is to define walls, which can also be created in the same ways as beams. Line selection can be done directly in the inspector window, graphically in a 2D view, or graphically in a 3D view. To do it, select the appropriate mode in the graphic menu, 3D view selection. After turning on the walls on the selected lines, we define the thickness and material. To obtain an advanced solid shape, turn off the simple solid option. The user has the possibility to change the contour parameters on the upper and middle levels. The value of the scale X parameter for the upper contour is changed, which causes it to be extended in the X direction. When the curve generatrix option is enabled, the middle contour can be scaled. In the example, the value of the scale Y parameter is changed for the middle contour, which causes the solid to be shaped vertically in the Y direction according to the parabola. As before, all elements defined so far automatically adapt to the new shape. The IgentForm program also gives us the possibility to move the upper and middle contours by any value or their positioning relative to the points or lines of the lower contour and the possibility to rotate them. In the example, the upper contour was shifted by 3 meters in the Y direction, which completes the formation of the side surfaces of the solid. We move on to the last stage, namely modeling the upper surface of the solid. To do this, we select a group of parameters describing the roof and turn on the grid on the roof. The program allows us to use a rectangular or radial grid. The former will be used here. Parameters number of axes in X and Y direction determine the spacing of roof beams. By default, the spacing is the same in the projection on the XY plane. Beams can be assigned any cross-section previously defined in the cross-section database, including trusses. Individual groups of parameters can be freely collapsed or expanded at any time, focusing on a selected part. The next step is to determine the parameters of the upper plate. In this case, we change its thickness and material. Finally, we take advantage of the unique functionality associated with the contour lines and points, namely the possibility to use them to form the roof surface. We select the center point and raise it to the desired height. Next, we can use the roof shape option, which defines the curve according to which the roof will be formed. By default, the program proposes a sine wave. We can define this curve by selecting it from the list of predefined curves such as parabola, ellipse, Gauss curve or circle, as well as use any curves that can be saved to the cross-section database. Such a curve can be changed graphically. The program automatically modifies the roof surface in real time. Sometimes it is necessary that the distances between the beams are the same, not in the XY projection, but on the roof surface, in order to equalize the dimensions of the roof slabs. This effect can be achieved in the program by disabling the equal spacing option or enabling the equal spacing on the roof option. The program will automatically calculate the axis coordinates. In our example, this functionality was shown for a roof shaped in the form of an ellipse. IgentForm program also allows us to define additional elements such as struts or railings. In the example, definition of railings will be shown on the selected edges. They also adapt automatically to the shape of the solid. We can define the spacing and cross-sections. If the required cross-section is not available at a given moment in the cross-section database, it can be easily added. In this case, go to the addition of the currently assigned cross-section, select the copy option and change the parameters. Then we assign a new cross-section to the selected element. Finally, surface smoothing option improves model visualization. Thank you for your attention, and I invite you to watch other videos which show amazing possibilities of parametric modeling.